What's up, guys? I'm back with another one again. I'm gonna be looking at paper 2 again for maths, grade 10, paper 2. And as you can see, this is a trick question. Okay, so let's get into it. So, the question reads RQ is a vertical pole. Okay, and so as we can see, that there's RQ. Okay, the foot of the pole Q is on the same horizontal plane as P and S. Okay, so as you can see, there's your horizontal plane P and S. Okay, and it says the pole is anchored with wire cables at R and S. Okay, and R and P. Okay, so they're saying there's anchors here at R and S and R and P. Okay, and the angle of depression from the top of the pole to point P is 47 degrees. So there's your angle of depression right there. And PR is 21 meters and QS is 17 meters. Okay. They all now ask you, and and the last statement is R angle PQ equals theta. Okay, and as we can see, that's what they're referring to right there. Okay, so we have all our information in. Let's get started with the question. So it says here, write down the size of theta. Okay, so they want to know now what theta is. So let's see here. So we can now say that 6.1, the size of theta. So let's see what we have, right? We know that we do not have the side here. We do not have the side here. Okay, we have an angle which is theta, and we have our hypotenuse, which is 21 meters. Okay, so how do I approach this? I could say that I know that angle P, which is equal to theta, right, is actually equal to 47 degrees, right? And why do I say this? Because I know that alternate angles are equal, right? I know that alternate angles are equal. Is it not? Okay, because we can see there that this is alternate. Can you see there? Okay, it's making a Z, or you can say, if you turn it around, it's making an N. Okay, so we now know that theta equals 47 degrees. Okay, so we have an angle and we have one side. So what can we do? So they want to know what is the size of theta. So we found it. Okay, so theta is 47 degrees. Apologies, my mind is a bit further ahead. Right, so there we actually have it. Okay, the question was find the size of theta, and we know that theta is 47 degrees because alternate angles are equal. Okay, next question. My mind is already, but then question coming after this. Okay, calculate the length of RQ. Okay, so this is where my mind was already. Apologies. So RQ, we know, is this vertical line over here. Okay, so let's call that there arc. Okay, let's leave it as RQ. So let's say now that 6.2, right, RQ equals, okay, what is it going to equal? We have the angle now, and we want to find the side. Okay, so what are we going to say? What can we use? We can use, seeing that we have the angle and we want the side opposite the angle, we can use sine. Okay, so we can say sine of 47 degrees equals opposite over my hypotenuse. Okay, all right, so what's that going to be now? So we can say that sine 47 degrees equals RQ over 21, right? The hypotenuse, remember the hypotenuse was 21 meters. Okay, so again, if you caught my previous videos, you would see now we can put sine 47 degrees over 1, and then we can cross multiply. Okay, so we're going to say here we can say that therefore RQ equals 21 sine 47 degrees, right? Okay, and then we can head over to our calculator. Okay, and then we can just piece in there 21 sine 47 degrees, and you can see there that RQ is equal to 15.36, right? 15.36. So we know that therefore RQ equals to 15.36, rounded off to 2 decimal places. And we also know that based on the information given that the unit of measurement is meters, right? As we can see there, our hypotenuse was in meters, so that means that RQ will also be in meters, okay? So we found RQ now, and we know that it is 15.36 meters, right? Next question is, hence, 6.3, hence, calculate the size of angle S, okay? So I'm actually going to get some space here for this question, because we just ran out of space. I don't want to move too far from the question paper. Okay, so let's just remove all of this. We already found all those unknowns. Alright, so question is 6.3, hence calculate the size of angle S. So they want this angle over here on this opposite side. They want that angle there, angle S. So we know now we have two sides and an unknown angle. So what can we do? What is adjacent and opposite to angle S? We know it's 15.36 and 17 meters. So we can basically now use the tan of angle S, we can say, is equal to opposite over adjacent. Alright, so let's move this bit up here. And we know that opposite to angle S is 15.36, and our adjacent to the angle there was 17. So therefore tan of angle S equals 15.36 over 17. Okay, and now we know again we have to do the shift. Okay, so we know that angle S equals the tan of minus 1 of 15.36 over 17. And again, you can move over to your calculators and you can say that the tan of 15.36 over 17 equals, right, we get a value there of 0.015. Okay, and that's incorrect because I didn't say shift tan. Right, shift tan 15.36 over 17, and there we have a proper answer. Now we have 42.098 degrees. Okay, and that's gonna round off to 42.1 degrees. Okay, that's gonna definitely round off to. So we now know that angle S equals 42.1 degrees. Okay, alright, so let's piece that bit of information in there. We now know that this is 42.1 degrees. Okay, alright, so let's look at our last question. 6.4 says that if P, Q, and S lie on a straight line, how far apart are the anchors of the wire cables? Okay, so remember the anchors are there, and they say if P, Q, and S is on a straight line, how far apart are the anchors? Okay, so we know that Q to S is 17 meters. However, this side here remains unknown, and I guess we can go one of two ways. We can use Pythagoras, or we could use sine, cos, or tan. Okay, and the easiest one would just be to just go into Pythagoras. So we could say now, so let's look at this. Okay, so 6.4, we're gonna have RQ squared plus PQ squared equals PR squared. Okay, so what's that going to give you? We know that RQ is 15,36 squared minus PQ squared, which is unknown, equals RQ squared, right? So it's 21 squared. Okay, let's move that a bit up here. So we now know that we can say that PQ, apologies guys, this must be a plus. Okay, let me just get this out of the way here. Okay, we can now say that PQ squared equals 21 squared minus 15.36 squared. Okay, and again we can go to our calculators with this one. Okay, we can say that 21 squared minus 15.36 squared equals 205.0704. okay, so let's go back there. So we can now say that therefore PQ squared equals the square root. Before we do that, let's say it is 201.0. Let's just get that number again. 205.0704. 205.0704. Okay. Let's put it there. 205.0704. Okay, so now we know that therefore PQ will equal the square root of 205.0704. Okay, you guys still following me? So let's check that out on our calculators. Okay, we're gonna get the square root of that. So let's clear this. Say the square root of 205.0704, and we get a number of 14.32. okay, 14.32. so we now know that therefore PQ equals 14.32 meters. Okay, but remember, we're not done. The question said, how far apart are those anchors? Okay, how far apart are the anchors? So they want to know how far apart is this distance over here. Okay, so we still need to get that bit of information. So we now know that this number here is, we just found it now, it's 14.32. Okay, so all we're going to do now is we're going to add PQ plus QS. Okay, so let's do it here. So how far apart? We can now say that PQ plus QS equals 14.32 plus 17, and then you can just do the math, and that's going to give you 21.32 meters. Right? You guys with me? absolutely incorrect, right? Let's do it again. So we know that's going to give you 31,32 meters. Okay, you guys with me? And for those that didn't do that math in their head, okay, what you can do is you can go over to your calculators and then you can do it there. You can say 17 plus 14.32 and you get 31.32. Okay, alright guys, and that is all for today. Please like, share and subscribe. Okay, until next time.